Hi there. So welcome back to chemistry. This is our first lesson actually in the environmental chemistry unit. In this lesson, we're going to take a look at ways to measure air quality. Now, um, I did load up the video for you, a YouTube video called London's Killer Fog from SciShow Science, one of my favorite YouTube channels. You can take a look at it on your own. I'm not going to play it for you here. It's about 5 minutes long, but it's well worth your time. It tells an interesting story about how the smog in London was so bad that one year it actually killed more than 1,000 people. That didn't happen 200 years ago or 300 years ago. It only happened about 30 or 40 years ago. It happened in the 1980s. The smog was that bad. So what we're going to do in this lesson is take a look at some of the ways that we can monitor air quality, how we can determine air quality, and some of the effects of poor air quality on human health. Okay, so to begin with, we use something called the Air Quality Health Index in Canada. The Air Quality Health Index is measured by Environment Canada, although it's monitored by various local and provincial institutions. It lets you know how safe the air is for people with health problems. It's based on the following indicators: ozone at ground level, or O3, particulate matter, PM2.5 and PM10, and nitrogen dioxide. So ozone is something you might be familiar with. It happens in, or it's found in the upper atmosphere, and you may have learned about how the ozone layer protects us from the sun's harmful radiation. Well, it's great way up high in the atmosphere, but down at ground level, it's really bad for you. Ozone is a molecule of 3 atoms of oxygen combined together. But as you're somewhat familiar from the chemistry unit, oxygen prefers to be just 2 atoms together, O2. So when O3 comes in contact with other oxygen, it takes another oxygen atom away from whatever source, combine it together so that O3 becomes 2 O2 molecules. Unfortunately, when you breathe that in, it means that it's taking that oxygen away not only from your lungs, but also from the bloodstream. It takes the oxygen right out of the alveoli in your lungs, the capillaries where the oxygen is supposed to go into your blood. The O3 or ozone actually leaches or steals that oxygen out of your blood. It makes it difficult for your red blood cells to get the oxygen they need so that your cells can do their job. Particulate matter PM2.5 and 10 refers to 2.5 micrometers. So that's the diameter of one particle of this matter. That's very small. That's things like nitrogen oxide, nitrogen dioxide, carbon dioxide, carbon monoxide is very small molecules. Particulate matter of 10 micrometers in diameter is something larger like dust, pollen, dirt, things like that. Nitrogen dioxide is a natural part of the nitrogen cycle, but we increase the amount of nitrogen in our environment using man-made or artificial fertilizers. So through the Haber-Bosch process, which some of you looked at a few weeks ago, we're able to take nitrogen from the air, which is about 80% nitrogen, the air that we breathe. We take the nitrogen from the air, and we're able to condense it and put it into a solid format, which we can use for fertilizer. Unfortunately, excess nitrogen finds its way back into the atmosphere, where it mixes with rain in the clouds and it falls as acid rain. We're going to take a look at some of the detrimental effects of acid rain later on in this lesson. I'm going to show you an example of the Air Quality Health Index from a local group that measures air quality in the Calgary area. It's called the Calgary Air Shed. Right? Remember, you learned about watersheds, areas where water flows from the top of the mountain down into the ocean. Well, an air shed is a similar idea where the air in an area kind of has similar characteristics. It's shared by the same meteorological, the same weather formations. So on the Air Quality Health Index, or AQHI, from 1 to 3 is considered low risk. People in good health and poor health with chronic health conditions can go about their daily activities. 4 to 6 is a caution area. People with health problems need to be careful. 7 to 9 is quite high risk. And then 10 plus is considered very high risk. If you think back to last spring when we had the forest fire smoke so bad in Calgary, people with health problems were told not to go outside because the air quality was 10 plus, meaning just about as bad as they can measure it. It's really dangerous for people, elderly people, people with breathing conditions, to go outside. Okay, so the Calgary Air Shed is an area around Calgary, not just Calgary itself, but it's a much wider area, and it does include Airdrie as well. The Calgary Air Shed has a website where they report real-time remote sensors on the air quality in the Calgary area. There's actually, this isn't the one that we have, but there's one really close to Croxford. It's just over by the Ball Diamonds in Chinook Winds Park. This over here on the side is a copy of the AQHI report that I pulled off of the Calgary Airshed website on Thursday. So on Thursday, the air quality for Airdrie was ranked at a 2 at the time. Average throughout the day is a 3, the night was a 3, and then on the Friday, air quality was predicted to be a 3. Now these stations here monitor a number of different conditions, but it's the same 3 big things that we just looked at on the other slide there. So we're looking at ground level ozone layer, ground level ozone levels. We're taking a look at particulate matter, 2.5 and 10 micrometers, and we're taking a look at amount of nitrogen in the atmosphere. These sensors are all around Alberta, and they actually measure the air quality every hour and send them wirelessly through Bluetooth or Wi-Fi to labs in Edmonton and Calgary where the data is compiled together. You can actually apply to have one of these installed near your house. There just have to be a few special considerations so that it's not tampered with. So what are the effects of air pollution on humans? Well, fine particles, those are the smaller ones like carbon dioxide, nitrogen dioxide, things like that, that can cause shortness of breath, wheezing, coughing, chest pain, and fatigue. The fatigue is because your body isn't getting the oxygen it needs in order to fuel the cells to do its job, to do the work. Fine particles can make these conditions worse: cardiovascular and heart disease, and asthma and COPD, chronic obstructive pulmonary disease. Ground level ozone is slightly different, but similar effects. So it can cause difficulty breathing deeply. You can breathe, but you can't breathe deeply because when you breathe deeper, you pull that O3 way down into your lungs and it pulls that extra oxygen out of the alveoli. It steals more oxygen from your body. It does cause shortness of breath, sore throat. Because it's taking oxygen away from your cells, it feels like it's actually burning, literally like it's on fire. Like you had some hot sauce and it went down the wrong way. And then wheezing and coughing, and again, fatigue because your body doesn't get the oxygen that it needs. Ozone can make these conditions worse: asthma and COPD and emphysema. So ozone is a naturally occurring substance. It's an inorganic compound, meaning it doesn't have carbon in it. In the upper layers of the atmosphere, it helps protect Earth from radiation in the stratosphere, but it's hazardous to breathe at ground level because it takes oxygen molecules out of your lung. Now, ground level ozone is caused by 2 things mixing together: smog and sunlight. Smog is just air pollution caused specifically from the burning of fossil fuels. So we have nitrogen dioxide, and VOC, volatile organic compounds. So that basically just means things that evaporate really quickly. They mix together with sunlight at ground level and it creates smog, but it also creates that dangerous O3, that ground level ozone, which steals oxygen from your body. Now, we talked about the nitrogen. The nitrogen cycle is a lot like the carbon cycle or the water cycle. It's a natural cycle where nitrogen, which makes up about 80% of our atmosphere, is absorbed by plants into the soil and into the water. Of course, when sunlight evaporates the water, the nitrogen turns into a gas and it goes up to the atmosphere. Nitrogen in the soil is naturally absorbed by plants. It's one of those macronutrients that we learned about in last week's lessons. Plants absorb the nitrogen, uses it to make them nice and leafy green. Animals eat the nitrogen, of course, the nitrogen-enriched plants, and then a lot of the nitrogen is passed out through gases or solid waste, which can either go back into the soil or they can break down and go back up into the air. Now, the problem is that when we have artificial fertilizer in the soil, it increases the nitrogen in this nitrogen cycle. When that goes back up into the air and mixes with some of the smog in the air and the moisture, it creates acid rain. Acid rain, of course, has some harmful impacts on plant matter, buildings and infrastructure, and also on aquatic ecosystems. And we're going to take a look at the effects of acid rain in the next lesson on water quality. So the acid rain pathway, really quickly, is another example here. It shows in this case, sulfur dioxide and nitrogen dioxide rising up from the fossil fuels. Here's the sulfur dioxide from the burning of fossil fuels in power plants. We learned, of course, back in the electricity unit, that the province of Alberta burns coal, it burns coal to create the majority of the electricity used in the province of Alberta. Burning coal reduces a lot of sulfur into the atmosphere, which mixes with moisture and falls as acid precipitation. There is such a thing as acid snow, by the way. That's why we call it acid precipitation. And then again, it has dangerous effects on plants and also on aquatic ecosystems. It tends to not only kill animals that live in the water, but also animals that live near the water, like birds and various mammals like muskrats, beavers, things like that. The effects of acid rain are difficult to mitigate, they're difficult to fix, but they're pretty easy to prevent. We've made a lot of efforts in our society to try to reduce the effects or the creation of acid rain. Some of the effects of acid rain, the erosion of buildings and infrastructure. So this actually is a story from the city of Calgary just a few years ago. Acid rain weakened some buildings in downtown Calgary, just south of the Centre Street Bridge, and the bricks actually fell. There were some vehicles, luckily nobody was harmed in the parking lot, but some vehicles were damaged by it. This is another example of damage to infrastructure in a cemetery. This is a corrosion caused by acid rain or acid precipitation in the area, and it eats away at the calcium-rich or mineral-rich marble and granite that the tombstones are made from. It's very much like pouring vinegar, which is an acid, onto baking soda, which is a base. The calcium part here, like calcium bicarbonate, the calcium in the marble and the granite reacts with the acid, and the tombstones actually get eaten away, or the headstones. It also affects fish development and aquatic life. So this is a normal pH, a pH of 5.5, and these are fish fry, so fish eggs that have hatched. In 5.0, that's just slightly acidic. It causes the development of the fish to slow down considerably. And then in just 4.6 pH, not a big difference between 5.5 and 4.6, it kills the majority of the fish that are born. So that can have a big impact on our local fisheries, waterways, and for those people who rely on the fish as a food source, some of the First Nations peoples in the province of Alberta, it can have a big impact on their ability to feed their families and support themselves. Okay, and finally, acid rain can prevent crops from developing properly. Now, in Alberta, we're pretty spread out and we don't have the population density that cities like New York and LA have. So we don't have this much of a disastrous effect on plant growth in Alberta. This is actually taken from India, where the population is much greater and the acid precipitation is much higher because of all of the fossil fuels being burned. This isn't as much of a problem in Alberta, but the first two are a pretty big problem for us. So how can we reduce air pollution? Well, there's 5 easy ways to improve air quality. First, reduce our use of fossil fuels. And we've done that a lot by making sure we use fuel efficient vehicles, alternative energy sources, different lighting sources, LEDs rather than incandescent bulbs, things like that. I should use this lamp for TikToks, like everybody else, right? Reduce burning yard waste. It's actually against the law in the city of Calgary to burn leaves, sticks, twigs, branches, things like that. Rather than burning them, we can compost them. Encourage monitoring of industry emissions. So there are lots of groups that do willingly monitor air quality to make sure that they're not polluting the environment. And power plants in Alberta are really good for that, actually, complying with air quality monitoring regulations. Again, mulch or compost yard waste rather than burning it. So the grass clippings, rather than throwing them in the garbage where they're going to go to a landfill, decompose, and put all that nitrogen back into the oil, if you mulch them, put them back into the soil, or compost them, that nitrogen gets broken down and it gets stored in that mulch. And then when you use that mulch on your plants in your garden, it puts the nitrogen back into the soil rather than releasing it into the atmosphere. Finally, one of the easiest ways we can reduce air pollution is by making sure our vehicles are properly maintained. Okay, so here's what I want you to do. Now that you've learned about air quality monitoring in Alberta, use the information in this slideshow and video to answer the 5-question air quality Google quiz. That quiz should only take you maybe 5 or 10 minutes to complete. You're free to use this video if you want to, or you can look up the answers online. I just want to know that you learned something about monitoring air quality. And when you're finished, move on to the next lesson on measuring water quality. When that's all done, you can move on to the final project for the year, which is a short research project that'll be due next week. If you have any questions, let me know. Otherwise, I'll see you in the next video. when you're ready.